Okay, graphing linear equations. Three important concepts I want you to think about in this video. First of all, we're going to learn about what a system of linear equations are. We're going to learn about the solution of a linear system and the point of intersection. What are those things? Let's find out. Number one, a linear system of equations is two or more linear equations in the same variable. So an example that I have here is you're used to looking at 3x plus 2y equals 4, or you might be looking at negative x plus 3y equals negative 5. Those two are now, you're going to work with both of those at the same time. And basically what you have is this, it is a system because this variable is the same. Notice the power is a 1 here, 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 and here. When the powers are the same, it's the same variable, just like combining like terms. A system, you have two or more. I could add another one here, maybe something like x plus y equals 6. And we could make all three of them, see if all three of them find a solution for all three. Number two, a solution of a linear system is the xy coordinate. The xy coordinate that will make each equation true. So in that previous example, we're going to find an x and a y that works for both of them. And when we find that x and y is going to be called the solution, which is also called the point of intersection. What does it look like on a graph? Well, for instance, if I took those two, equation 1 and equation 2, and I plugged them in on a coordinate plane right here, equation 1, equation 2, and where they come together, that's the point of intersection. You're used to looking at intersection for the y-intercept, maybe the x-intercept over here. Well, this is going to be where these two equations come together, so it could be anywhere on the plane. These happen to come together right here at positive 2, negative 2. So let's look at an example. Find the point of intersection. I'm just going to leave this one alone because it's kind of funny. All right, I'm going to give you an equation. 3x plus 2y equals 4. And equation number 2, negative x plus 3y equals negative 5. What are we going to do? We're going to actually just take those and put them in slope-intercept form, which you're used to. Put them in slope-intercept form for this one, and put them on the graph. And when I graph them out, I'm going to estimate the solution this time. I'm taking a look and I go, I think it's going to be at 2, negative 1. Well, once I do that, I'm going to take and plug it in. So I take my original equation right here, 3 times 2 plus 2 times negative 1 equals 4. I'm just plugging in the x for x, the y for y, working it out, and I'm happy. 4 equals 4. I do the same thing for equation number 2 right here. I just plug in again the x for the x, the y for the y, work it out, negative 5 equals negative 5, and it checks out. We're good with that. So that's just finding the point of intersection. You're going to take the equation, put it in slope-intercept form, graph it, just find out where these guys connect, and estimate. You go, well, that looks like 1, 2, and negative 1. 2, negative 1. And I'm going to plug it back into the equations and see if it works for both of them. If it works for both of them, we're good. Okay, just another example right here, example number 2. Graph and check method. Same method I just showed you, we're just going to do another one. Equation says x plus y equals negative 2. Equation number 2, 2x minus 3y equals negative 9. First thing, put it in slope-intercept form. Slope-intercept form turns out like y equals negative x minus 2 and y equals 2/3 x plus 3 for equation 2. Take these and plot them and graph them on your coordinate plane. You can see my y equals negative x minus 2 comes out up here. You know, negative 2 is the y-intercept, so there's my y-intercept down here at negative 2. For this one, the y-intercept was positive 3, was up here, so I took the slope for these, you know, positive slope here, up 2 over 3, up 2 over 3, up 2 over 3. That gave me that type of incline. This one here, what's my slope right there? That's negative, and it's just a negative 1. You don't see it, but remember, that's implied. Negative 1, so that from here, it was down 1 over 1, down 1 over 1, down 1 over 1, if you remember that. Well, where they came together was pretty close to negative 3, 1, if not right on that. I just now take the negative 3, 1. This is the check part of it. I plug it in, and you can see that I'm going to plug it into the original. Negative 3 for x, positive 1 for y. I work them out. Negative 2, in fact, does equal negative 2. Take the original equation number 2 down here. Negative 3 gets substituted in for x. 1 gets substituted in for y. I do the calculation and evaluate and find out, yes, negative 9 equals negative 9. It checks out. So this solution ends up being negative 3, 1 for the two equations. In summary, use a graph and check method to find the solution of a linear system. What do? First, we write each equation in the easiest form that we can think of, and that's slope-intercept form. Rewrite it in there. Then, graph it. Graph the equation. Graph both of them. Find out where they intersect. Maybe they won't, but in this case they will. Estimate the coordinate of the point of intersection. So after you graph them, you'll look for the point of intersection, make an estimate. Last thing, just check it. Put it in there, substitute, and evaluate. And with that, we'll be on to our next video.